This lecture will cover section 2.3 on functions. Alright, so first what we want to do is get out of the way a couple of definitions. A relation is simply a set of ordered pairs. So a set, if you think about a set of dishes, it's just a group of things together. So a set of ordered pairs, we may draw like this, and then 1, 0, 2, 1, 3, 2. Alright, and it could be any amount of ordered pairs. That makes a relation. Now, a function is a relation for which each distinct value of the first component of the ordered pairs, there is exactly one value of the second component. That simply means the x value, that first component, is not repeated. Every x value is different. None of them are the same. So what we're going to do is we're going to look at a couple of relations and decide if they are functions. Alright, so first we're going to look at the relation f. And f is simply a name. It just helps us identify and differentiate between the different relations. And these ordered pairs have simply been made up. Alright, so when I look at the relation, I have the ordered pair 1, 2, the ordered pair -2, 4, and the ordered pair 3, -1. Alright, and so when I look at this, I'm going to look at the x values, and if they are all different, they are, then we can say yes, it is a function. Alright, then looking at relation G, its coordinates or the ordered pairs are 1, 1, 1, 2, 1, 3, and 2, 3. So I'm going to look at the first component or the x value in each ordered pair. And if at any time any of them are the same, then we would say it is not a function. And here we have a couple of x values that are the same. So we're going to say no, it is not a function. Alright, then looking at relation H, the ordered pairs are -4, 1, -2, 1, and -2, 0. So when I look at the y values, the x values, I see that these two x values are the same. So we would say no, it is not a function. Alright, in a relation, which is, remember, a set of ordered pairs, the set of all values of the independent variable or the set of all the x values is known as the domain. And you're going to see domain and range several times in the next few sections. So make sure you get that clear in your head. Alright, and the set of all the dependent variables, or the y's, is called the range. Alright, so the domain is simply all of the x values. It's a set, so we're going to put them all together in one set. And the range is the set of all the y values. Alright, so let's take a look at this relation. Alright, first we want to know, is it a function? And then we're going to decide what's the domain and range. So looking at all the x values, we have 3, 4, 4, and 6. We would say no, it's not a function because it has some x values that are the same. And then we want to talk about the domain. So the domain is going to be the set, and that's that little squiggly line identifies set, all of the x values. So we have a 3, a 4, and a 6. Now the values that repeat, there's no need to write them twice. Alright, 3, 4, and 6 are the only values that are in the x position. Alright, the range is the set of the y values. That's going to be -1, 2, 5, and 8. So -1, 2, 5, and 8 are going to be our range. Alright, looking at the next relation, it looks a little bit different, but still a relation. This is going to be your x's, and this one's going to be your y's. Alright, so 4 goes to 100, 6 to 100, 7 to 100, -3 to 300. So it would look something like this. 4, 100, 6, 200, 7, 200, and -3, 300 is what the ordered pairs would look like. We simply look to see, do any of the x values repeat? They do not. They're all different. So we can say yes, this is a function. Then to write the domain, put our little set there. 4, 6, 7, -3 are all the different x values. And then the range is going to be the different y values. Make sure it's a set. 100, 200, 300, and close our set. Alright, in the next one we have -5, 0, 5 are our x's. None of those repeat. So we can say, yes, this is a function. And the domain is going to be -5, 0, 5. And the range is just that one value, 2. Alright? Alright, now we're going to look at each of these relations and give the domain and range of each. We're simply looking at the x and the y values. So here we just have some random points put together, so I'm just going to go through and look at what each of the x values are. They don't have to be in any certain order. -1, 0, 1, and 4. And then my range is going to be the y values of those points. 1, -1, 2, and -3. Alright, next we have a graph. And so I want to look at the graph. I'm looking at what are the x values. So here I'm looking at, here's my x-axis. Those are those values that are here. Alright, I can pick any point in here. X, there's some point on the graph, some point on the graph. And so when I look at the graph, my x values are somewhere between -4 and 4. And so what I'm going to do, instead of writing it as a set, I'm going to write it in what's called interval notation. Alright, and that simply says here's the first value of my domain and it goes all the way up to this value. So these two values and anything in between them. Then the range has a list because there's an infinite amount of numbers in between there. I couldn't list them all. Alright, lots of numbers in between -4 and 4. Think about fractions, decimals, and such, so it's much easier. You'd be here forever trying to write out all the values between -4 and 4 if you didn't use interval notation. Alright, and then the range is going to be on the y-axis. Alright, and so that's going to be all the values between -6 and +6. Notice I also put those in interval notation. Alright, when I look at the next graph, thinking of the domain, all the x values, alright, this is a linear equation. There's some arrows there on the end of those lines, and those arrows mean that this line goes on forever in both directions. So as I move either up or down the line, I'm continuing to move out the x-axis in both the positive and negative directions. So I can say that this domain goes on forever from -infinity to +infinity because this line just keeps on going, extending out this x-axis, and we can keep going on forever. And then the range is going to work the same way. Alright, and eventually we're going to talk about some equations and talk about their domain and range, and you're going to see how all linear equations have the same domain and range. Same for the next one. And you'll see how certain equations have similar domains and ranges. Let me say that. Alright, the next we have a parabola. Alright, and it's going on forever in both directions here, in the negative x direction and in the positive x direction. So we can say that its domain is -infinity to +infinity. And its range is the y value, so we're looking at where does this graph, what y values does it have. And the lowest y value it has down here at the vertex is -3. And then as the x values increase, so do the y values. So they too will go on to positive infinity. Alright, so what we want to do is, sometimes given a graph, we can determine if the graph is a function simply by using something called the vertical line test. And it is, we just take a vertical line, and if we can draw a vertical line anywhere on the graph and it touch more than 1 point, then it would not be a function. Alright, so when we look at, so it's just another way. Instead of, if you have a graph, instead of trying to find a whole bunch of points to see if the x values repeat, you can use the vertical line test on a graph. Alright, so we're going to use these graphs we have up here in number 3 where we wrote the domain and range. Alright, and if I draw a vertical line anywhere in these graphs, these are just points, none of my vertical lines would touch. So if I drew a vertical line here, and I mean, you can look at it and tell. You don't have to draw a whole bunch of vertical lines, but you can see that none of my vertical lines touch more than 1 point. So we could say for A, alright, that it is a function. Alright, then when we look at graph B, I can see several places where if I drew a vertical line, like let's say here, it touches the graph in this point and this point, so it touches more than one location on the graph. So where x has a value of 3, it has 2 y values, so that would be 2 points that had the same x value. So we would say this is not a function. And then if we look at C, linear equation, the graph of that is a straight line. There's nowhere on there that I could draw a vertical line and it touched more than 1 point. And then this is a quadratic graph, so that parabola, nowhere on there I can draw a vertical line and touch more than 1 point. So we would say that is also a function. Alright. Alright, so moving forward, talking more about domain and range and some functions. Alright, the domain of a relation is assumed to be all real numbers that produce real numbers when substituted for the independent variable. And that's just some information to give you there. Alright, we want to decide whether each relation defines a function and then give its domain. Okay, so if you think about this equation right here, it's a linear equation. And we're deciding what x values and y values go in there. If I pick a value for x, any value, alright, what y value will it produce? So let's say I picked a 1. 1 plus 4 would say y is 5. That would give me this value right here. Alright, now if I pick 1 again at some other point in time, is it going to give me some other value than 5? No, it's always going to give me a 5. So there's no time when I'm going to have repeating x values in a linear equation. I can't fill in one value and get 2 different y values where one x value has multiple y values. So a linear equation is a function, and its domain is always negative infinity to positive infinity. So anytime you see a linear equation, there shouldn't be much thought given as to what the domain is, because it is always negative infinity to positive infinity. Alright, also thinking about the next equation, it is a radical equation, a square root equation. So you have to stop and think about what are some restrictions on radicals. Well, they can't be negative. Alright, so for radical or square root, let's say square root, keep it correct here, square root equations, alright, I can't pick some value here and let's say a 1, and I say 2 times 1 is 1, 2 times 1 is 2, minus 1 is 1, the square root of 1 is 1. If I came back and filled in a 1 a couple days later, I'm still going to get a y value of 1. So I can't fill in the same value of x and get a different y value. Alright, so we can say this is a function. Alright, and its domain will always be, here's how you find the domain. You take the radicand and you set it greater than or equal to 0, because we need to know what values of x will give us something 0 or greater.